So we'll continue. We ended with anytime you see a fossil, you have a sedimentary rock. In this picture, we see sedimentary rock, and in the rock are these impressions left behind by a dinosaur. These are dinosaur footprints. This you can see if you go up into Connecticut on Route 91. There's an old, it's kind of like, it's not really like a museum, but it's a little bit like that, where they have some dinosaur footprints and they have information about the period of the Earth's history when they were formed, probably during the Triassic. It's I'm not sure actually, now that I say it. So here we have a cast of shells that was made in some kind of sediment. The shells are long since gone, but the impression they left was left behind, and that would then be considered a fossil, a record of life at the time the sediment was deposited. The steps in fossilization are not complicated. Something dies, and that something really needs to have a skeletal system, exo or internal, and an external skeletal system or internal. In this case, the little cartoon has some kind of dinosaur, and the soft tissue all decays away, leaving behind the bones. The bones themselves will eventually decay, but before that, if they get buried into a low oxygen environment, the rate at which they will decay, the bones, will be slowed down, and in time they can leave a cast in the ground, or should I say a mold, not a cast. They can leave a mold in the ground, which then is later filled with water and minerals, which then solidifies because the water is driven out by the pressure from above. And what you are left behind with is not the bones of the original organism or the original bones of the dead organism, but rock that is in the shape of the molds left behind by those bones. So first, the soft tissue that exists during life decays, leaving behind only the hard parts. Second, hard parts may be transported and broken. This causes the fossilized remains to be incomplete representations of the living animal. Often we don't find complete fossils. It's much more common to find a fragment of a shell or bone than it is to find a complete skeleton. Third, and most important, hard tissues become buried and altered. In most cases, this involves destroying the original material from which the hard parts were made, as minerals are slowly dissolved and replaced by new ones. Oftentimes, a hard part is dissolved without being replaced by a new material, leaving behind only an impression or mold of the original animal. If this mold is filled with sediment that is later cemented into a rock, it will make a cast of the original animal. And I think before I said that those first shells I looked at were casts. These are not casts. These would be the mold, right, leaving behind an impression. So here would be a fossilized, mineralized representation of a very important reptile. This is not a great photograph. I apologize for that. That is reptilian in all but this section, which is now believed to represent feathers. So this is then an organism that is a link between reptiles with scales and birds with feathers. This would be another reptilian with a interior skeleton, and you can see very small alligator, crocodile-like creature. Here's a dragonfly, which would be a mold more likely than an actual fossil of the organism. So made an impression in soft sediment, even the details of the wing pattern. Now, in the ancient past, there were dragonflies with wingspans upwards of 3 feet in diameter. So this could be a large fossil. I'm not sure how big this fossil actually is. There's no scale on the photograph that I found online. And then we get to hominid evolution, just to quickly remind ourselves that without fossils, we wouldn't have the knowledge we do about our reality, Homo sapiens, and how long we've existed as a species on the face of the earth, and our nearest relatives, Homo erectus, Homo ergaster, Homo habilis, Homo neanderthalensis. These are all of our most recent relatives, the ones from which we evolved and for which we only lived at the same time with Neanderthalensis and Heidelbergensis. I didn't mention that. So we lived at the same time with both those creatures. But the others have all reached a dead end. And you see that all of these have gone extinct. You can look over here and you see the Paranthropus. These are the P. robustus, P. boci. Then you have the Australopithecus, Africanus, Afarensis. Then you have, going even further back, Anamensis. And then we go back to a common ancestor with the chimp in this region. At about 7 million, 8 million, 9 million, we split off from a common ancestor with a chimpanzee, and this is the lineage that these organisms followed to lead to us today. And without fossils, we wouldn't have this story. Crystalline sedimentary rocks are an important type of rock. They're formed from both the evaporation of water leaving evaporite minerals behind and the saturation of water with minerals that subsequently crystallize. You see halite here, which we looked as a mineral. Well, it also can be formed in what is considered a rock salt. There are deposits of this in New York State from the Silurian period of the Earth's history. And here we have dolomite, which makes up dolostone. I showed this to you in a photograph just a couple of slides ago. Here's the actual rock, dolostone. You can see it's not calcite because it has this addition of magnesium. And again, forming out of supersaturated water in this case, right? More dolomite mineral than can actually be held by the water, and so the excess rains out and becomes a rock, forms a layer of sediment. The basic steps in sedimentary rock formation is that we have rock that had been broken down from other rocks, weathered. You can see these round particles must have become round by being banged together in water, being banged by particles that are blown in the air, abrasion, moving through typically streams from high elevation to low, broken down sediment. Again, the sediment is carried by the water, the wind, and ice. Glaciers can leave deposits of sediment. And then finally buried, compacted, and turned into, over time, a rock in the process called lithification. From sediment to sedimentary rock. Lithification involves compaction and cementation. You slowly compress the sediments to the point where they are as close together as they can be, and then between them, over time, typically a calcite cement will hold them together. Weight pushes the sediment together, or one could argue weight is, of course, mass plus gravity. Pore space decreases, water is forced out of space and evaporates and leaves behind minerals that cement the sediment together. How can we tell if we're looking at a sedimentary rock? Again, we look for layers because the rocks are always typically deposited horizontally. We look for grains that are easy to feel and knock off. This is a grainy sandstone. It's easy to feel and see the grains of sand. And we look for fossils, like this trilobite from the Cambrian period of the Earth's history, probably found in Morocco. A lot of trilobites found there and sold to people. These are called ripple marks. These are from a rock which is quite old. I don't know if I can read what period it is. No, I can't in the picture. Quartzite sandstone, though, or quartzitic. It's not a quartzite, it's quartzitic, which means it's rich in quartz, and it's reddish because it also has hematite in it. And Here we see an example of the present being the key to the past, where the present shows us a location on the earth that we can visit, where you see ripple marks made in a mud flat at low tide, or are exposed at low tide. They're not made at low tide, they're made at high tide. And they match very well what we see in a rock that is millions of years old. So from the past, we find the rock, and in the present, we try to interpret, based on what we see now, the kind of environment that this must have formed in the Earth's distant past. Now, you need to know how to use this, which is the sedimentary rock diagram on page 7 of the Earth Science Reference Table. You have two types of sedimentary rocks: the inorganic land-derived sedimentary rocks and the chemically and or organically formed sedimentary rocks. Your inorganic land-derived sedimentary rocks are made of clasts, clastic or fragmental material. The grain size is either pebble, cobble, boulder embedded in sand, silt, or clay, just sand with some silt and clay, or the largest particle being sand with silt and clay, silt as the largest particle, perhaps with some clay, and then only clay. These are the way in which we identify sedimentary rocks that are inorganic and land-derived. What is the composition? Typically minerals that have not weathered away, so quartz and feldspar you'll often find from granites, other igneous rocks. Clay minerals that have formed from other minerals due to weathering. Then you can look at the shape of the fragments. If you have pebbles and cobbles and boulders and they're rounded, we say that rock is a conglomerate. If they're angular, these fragments of pebbles, boulders, and cobbles and boulders, we call them breccia. If it's sandstone, fine to coarse, sandstone. Or if it's sand that is fine to coarse, we call it a sandstone. Very fine-grained, siltstone. And compact may split easily. Shale, you can barely see the particles. You're responsible for these symbols. If you saw a symbol on a map that looked like this, you would know they were talking about a conglomerate. This would be a breccia, just little dots of sandstone, siltstone, and shale. On the bottom, to the chemically and or organically formed sedimentary rocks, we have your rock salt, your gypsum, your dolomite that are fine to coarse crystals and the texture overall considered crystalline. They have formed from precipitation and the evaporation of minerals out of solution, typically ocean basin that is, or a large lake that is slowly evaporating. The rocks would be rock salt, rock gypsum, dolostone, the symbols here. Our last two would be crystalline or bioclastic. Microscopic to very coarse would be calcite. Precipitates of biological origin or cemented shell fragments. So precipitates of biological origin or cemented shell fragments, so be called bioclastic. Limestone is your rock, and a brick wall is the symbol. Finally, coal, completely bioclastic. This is organic, compacted plant remains, bituminous coal. And then with that, we will finish and be done with sedimentary rock. Stopping my little timer, and we will continue with metamorphic.